So thank you, Sanjeev, for this introduction, and thank you for welcoming here all those people who are willing to work together for the coming weeks. So our group, as you mentioned, is coming from a European consortium, but we have also members from outside, as you will see in the team. So here, as all the partners of the project, everybody is not involved this year, but they will be in the coming years. So the topic of our research for the coming weeks is multilingual speech-to-speech translation for under-resourced languages. So here is a picture of the team from the first meeting we had in Le Mans. As you see, a few members were not here, so we added pictures from them afterward. I think there are still a few missing because we have a big team. Just a brief map with all the partners involved in this year project. So as you can see, they are mostly from Europe, but we have also US people, someone coming from India, and so on. So the goal of this team this year is quite simple as a goal. It's to be able to develop speech-to-speech and actually multimodal translation. That means you take some text or speech as input, and you want to output speech or text, and you can decide which modality in, which modality out. And so that's it. The task is very simple. You can add that what we would like to do is to have this kind of system, but that is easily adaptable in order to add new languages. That means languages which have very low resources. So we'll focus this year on, especially on Tamashek, which is a North African language. By the way, if anyone in the room or the assistants is speaking or understanding Tamashek, we would be very, very happy to know about it, because it's very difficult to evaluate the quality of a language nobody speaking in the group. This being said, I don't see any hand rising. So the idea is to adapt this system for under-resourced languages, and we put a strong assumption behind this. We assume that both modalities, text, speech, and all languages can be projected into a common subspace. So that's a very strong assumption. Of course, it's going to be demonstrated that it's totally wrong, but at least we will see how close we can come from this. And so the idea is to use auxiliary tasks and all the combination of ASR, TTS, speech-to-speech, information retrieval task in order to gather the information together coming from the speech or from the text. So in order to develop a multimodal, multilingual, extensible translation system, I already talked about the multimodal, the multilingual, and extensible. There's one thing I didn't mention yet, is that we want to be able to add new languages with low resources. But another thing we are interested in is also to work on the paralinguistic information. That means when you translate speech to speech from one language to another, what if you want to keep the speaker identity and inject it in the output speech? What if you want to keep the emotion of one speaker into the output language? That's the kind of things we are going to work on. And on the opposite, as soon as you're manipulating the speaker and emotion recognition information, you can also decide to anonymize, pseudo-anonymize. So there will be a work on analysis that we'll talk about later, in order to see which information is available in the subspace and also at the output. So as we have many people in the team, we split into 3 groups. So there will be one group focusing especially on encoding, one group focusing on decoding, and one group making the junction between 2 and working on the analysis of the entire system. So of course, in order to start with, we need to have the full encoding decoding framework, otherwise nobody can work together. So for the encoding team, in order to detail a little bit about the goals, the first thing we intend to do is to learn a multilingual, semantically aligned semantic space. At the moment, we are using LabC system. We plan to use also other systems like Laser, for instance. And the second goal is that if you look at speech system, they do not project semantically aligned sentences in the same space. So that's something we have to take care of. Then the kind of encoder we want to develop should be able to transfer for unseen languages for speech translation. So that's coming to the under-resourced languages, how you adapt your encoder in order to be able to take one language that has been never seen or almost never seen and to project in the same space for both modalities. Then one last goal will be developing new architecture for pre-training multilingual language models. This goal is already going on also. So if you look at where we stand now, we have a system working for speech retrieval. So speech retrieval, we are working at the moment at the sentence level. So that's one of the things we need to improve during this workshop. So we are taking multilingual system as input. And so far, we are able to project both speech modality and text modality into a common subspace. Here you can see a few dots joining together. And actually, once we can project this information in the same location in the space, then that means we can retrieve information multilingually. And so now you can see there's still a huge part of the system missing, which is the decoding part. I will talk about this just later. So in order to move from the sentence level, so the full sequence, to a real sequence level, we need to solve one big issue, which is that usually the decoders, and especially for TTS, for speech synthesis, they require a full sequence of embeddings or sequence of information and not only one single embedding, otherwise there's not enough information. So at the moment, we are working at the sentence level, and we need to find a way to really keep the sequence information, although you know that depending on the language, the order of the sequence will vary between the words and between the semantic content. So that's one big challenge, is how to get all these sequences, which are definitely not ordered the same way, into the same space. One idea also, this one is related to under-resourced languages, is how you can address under-resourced languages would be to work on family of languages, so that you have an encoder that is able to generate different representation per language family in order to be able to adapt quickly when you see a new language. For instance, Tamashek, as far as I know, Tamashek, it's more related to North African languages and Arabic languages than to Slavic languages. And so we can use this prior information in order to generate representation of Tamashek quickly by selecting the right family languages. And the point is that the system should do it itself. That means the system should detect that this language is closer to another one in order to pick up this information and use it. So now moving to the second part of the system, and let's assume that we will be able to generate this kind of very nice common space, multilingual, multimodal. What do we do with this in order to generate text and speech? Then if we assume we have a common representation in the middle, mixing both modalities, one question is, how far can you go with this joint representation to the decoder? And how do you divide information going to generate speech and the information going to generate text? Then looking at this, it depends on what information remains in the encoded space. And definitely, we'll see just later that if you put text as input for your system, it's very unlikely that you will get some speaker characterization information. So what do you do with this when you don't have it to generate speech? And on the opposite, if you have some speaker information within your representation, what do you do to generate text? Then one big question that will rise is the evaluation, because as soon as you speak about speech synthesis, speech generation, the question of evaluation is very tricky. And it's even tricky when you have native speakers in the audience to evaluate. But if I gave you Tamacek, actually, we already have very, very nice Thibaut generated, very nice samples of Tamacek. According to me, they are really, really good. But well, that's not enough as an evaluation. So there will be a work going on this. I think there's something. Yes. How can we evaluate generated speech and text? And ideally, so we have experts in evaluation in our group. Ideally, we would like to rely on automatic metrics, or at least to improve automatic metrics to work on this. I think that's all for this one. So the decoding team, actually, it will strongly depend on the encoding one. So depending on the status of the encoder, we plan different scenarios for the decoding team. In the best case, actually, that will be the lower part. That means we have an encoder that is able to really project everything in the same common space. Then the decoder team will be working on generating audio and text from this. But if the information is not so easy to use, we might have to go to this common joint representation and first separate this representation into something that is like we put WebLM here embeddings. That means something that is closer to speech embeddings, and that will be used to generate audio, or to BERT-like embeddings and then generate text. So this is the question on how far can we keep the joint representation in the decoder. And then coming back to paralinguistic information, if you have audio input and you want to generate audio output, then you might want to keep some information like the speaker identity, like the age of the speaker, the gender of the speaker, the emotions carried by the voice, and so on. And so how do you bypass actually the whole system, or is it possible to go through this common space, or do we have to extract some other information? And once you extract them, assuming you can, how do you plug them into the output speech? And so the question of evaluation of generated speech is a really, really tricky one. And actually, we have a scenario here in our data. For instance, the language we pick, Tamacek, we have audio in Tamacek, but we don't have any transcript in Tamacek. That means we have French transcription of Tamacek speech. And so how do you evaluate the quality of the audio that you generate, given that you don't have the incoming text? So assuming you want to do TTS, you don't have text in Tamacek, but you want to generate speech in Tamacek. So at some point, we'll have to have some loop in the system with ASR, TTS in order to generate data to evaluate and so on. And that's something we were planning to work on. So now we have one encoder, one decoder, or at least in a couple of days. And then there will be a lot of analysis going on in order to understand where the information is hiding and how much we can preserve, how much we can lose, we can hide. And so the analyzing team will be working on this. So this team is going to work very closely with the two others. And there's one first assumption we need to take into account is that if you take text or if you take speech as input, definitely you will not have the same information in the common space. As an example, the speaker ID, that's something I know about. It doesn't come from the text. You can look for some writer information into the style and so on, but definitely you will not get the age of the speaker so easily, or the emotions and so on. So you will have, even if you're in a common space, you might have embeddings that come from speech and embeddings that come from text. And so the analysis has to be different. Once you get this stream of embeddings, this sequence, then you can see how much sentiment, speaker, gender, language, semantics, speed, and so on is still carried by the embeddings. So that's an extrinsic task. But also there will be some analysis within the model in order to see, once you know that this information is here or not here in the output, then you can wonder where this information has been lost in the encoder, or where does it appear clearly. So there will be an analyzing on the neural networks, inside the neural networks, in order to see at which level the information is here or not. So that's the global framework my colleagues from the analysis team produced. So you see the encoder, decoder, the common space in the middle, and so here. And then after you have a list of information that is not exhaustive, but it's quite a lot already. So linguistic, phonetic, semantic, speaker, gender, speech style, prosody, speed, and so on. I think Nigel can be a great help in this task. Emotion, noise, and so on. And so we want to evaluate the difference for this information before and after the system in the common space. And then there is the question of adding or hiding information. So how much can we hide? How much can we inject in the signal? And how to do that? In order to add this information or to remove it, there will be different methods investigated. Of course, the gradient reversal is something that is quite commonly used to hide information. So that's something we are going to investigate. Just a word on the data. So for the analysis, actually, depending on the task, of course, we have to rely on different corpora, carrying use for speaker, for language, semantics, for multilingual speech, and so on. So far, for the analysis team, there's been some work carried on attentive pooling to improve the emotion recognition or speaker verification. And there's some work also on language ID using gradient reversal for tasks like ASR or SLU. And of course, this team has to stay very close to the decoder and encoder team. So on the to-do list for this task, once the common baseline, I mean, some of the common baseline are already agreed on. But one of the most important part of the work will be how to analyze, to measure which metrics to use to be very pertinent on this task. And then after, it will strongly depend also on the type of network used, because the analysis of the network itself, the architecture of the network, of course, is one question. That's all for the presentation on our team. So I will be very happy at the end of the week or next week to present where we stand, if you have any question.
There is a question from Alan Black. Alan, you can unmute and ask if you want.
Okay, thank you. Can you hear me?
Yes.
Yep.
Yes, we
okay.
can hear you.
Thanks. This is a really interesting project. You're really trying something quite ambitious. I'm quite excited about it. I look forward to seeing it over the next few weeks. One question which I have, which may be not relevant because it's outside your target, is when you start looking at low resource languages, how those languages are used in style are quite different. So if you look at Arabic dialects, they're really about speech interaction rather than written interaction, because you would use modern standard Arabic for that. And so looking at some of these low resource languages really cares about conversation and not about news, Wikipedia, Bible entries. Have you thought about how you might be able to optimize caring about the style of the use of cross-lingual information in order to be able to help the fact that you're probably going to be caring more about speech and conversational parts in the low resource language rather than long prose text?
Well, that's a very good question. No, so actually, I will just use a trick to answer. I think across the so-called under-resourced languages in the world, there are still a lot which are used for TV and radio broadcast. So At the moment, if we focus on TamaCheck, the data we have on TamaCheck, if I'm correct, but people from the team correct me, they come from news and from TV broadcast and radio broadcast. So in this aspect, it's still an under resource, but it's not related to your question. So that's why we'll be able to work on it more easily. Actually, the point you raise is actually very valid, and but I hope so in the Esperanto project, so not this year we will not address this, but in the Esperanto project, we have data collection going on in Cameroon, in Malaysia, in South America. Well, there's some in Spain, but it's not related. And this collection is targeting languages which are actually, in the case that you highlight, that means it's not news, it's not TV or radio broadcast, it's really conversational speech. And those are languages that are not widely broadcast. So we will come to this in the future, but for this year, I'm afraid we are not going to consider this.
Okay, good. Thank you.
Okay. Is there any other question in the online audience?
Yes.
Very big question to follow up to what you always said. So how much audio do you have in
19 hours? Yeah, 19 hours of audio, but no transcription. Yeah, Thomas, want to add something maybe? Yes. Yes, there's unlabeled data too. I mean, yeah, so Thomas mentioned the fact that we have 19 hours of TamaCheck, audio TamaCheck with French transcription, but actually there are a few more hours of audio TamaCheck with no transcription at all, even in another language. Yes.
When I was looking at the slide earlier, there was another language that was similar to TamaCheck mentioned in the slide beforehand. Is there anything on that?
Another language?
It was like it was also something.
Oh, no, I think it's in the slide. I think it's only TamaCheck that is mentioned. Actually, for the purpose of the study, we are going to also simulate probably the under-resourced languages using other languages and reducing the quantity of data that will allow us to have comparisons. But really, the most challenging task we address this year will be the TamaCheck because, well, it's really under-resourced for this task. Yes.
So I have a question about how are you going to evaluate the encoding part without having the decoding?
Yeah. No. So.
They can't get a question.
Yes. Sorry, I have to repeat. So the question is, how are we going to evaluate the encoding part without having a decoder? And the other way, yes. So one for. When we want to evaluate the encoder, definitely we have two ways to do it. The first one is what has been done already with Antoine and Samir, is to use information retrieval. That means we stay at the sentence level, and then we can at least get a clue on whether we project in the same part of the space. That's definitely not enough. And so now we already have a decoder starting from this space. And at the moment, we are using some ASR in order to, some text generation. So we can do the task of text to text or speech to text translation. But definitely we need the decoder, which is a problem because when you estimate the quality, you're evaluating also the quality of the decoder. So that's one problem we have. On the other side, when we want to evaluate the decoder, so as mentioned before, we are going to work, we are going to use common languages, I mean, with a lot of resources in order to first evaluate and train the system and have a first step in this direction. So for instance, we are using the speech T5, which is only English, but text and speech encoder. And then we will use the embedding produced by speech T5 in order to first get a first version of the decoder and work on it. Yeah, but that's something we will have to work closely between the two teams in order to update as soon as we can both sides. And at the end, I'm afraid at the end, the only evaluation really significant that we'll have is the evaluation of the whole system, because as soon as you start splitting, it's difficult.
Okay, so I have another question about Tamacek. Does it have any significant code switching? Is there a colonial language that's nearby? Is it Arabic? Is it French?
Excellent question. So I turn to the team. So the question, yes, do you know, have you listened to the data and do you know if there is code switching inside?
Alan just asked if you still have a question.
Yeah, yes. So just to repeat the answer, because I don't think it was.
Yeah, I can't hear it. Sorry.
Yeah. So as far as we know, but I guess you will not be very satisfied with the answer. It's mostly Tamacek, but there's a little bit of French code switching inside. We don't have the exact quantity of this, and yeah. So I'm afraid.
Yeah, I'm just wondering about bootstrapping or doing some keyword spotting where you might be able to get some anchor points. Even if it's in news, if it's going to have anything international in it,
yes.
Often there are more international words, so you can recognize Paris or London or Washington in it, and that sort of helps when you're doing alignment.
Yeah, probably. I think for those named entities or things like this, we can rely on the French transcription in order to find them. But after, it's more for the the words that are not named entities that it will be more tricky to catch. Yes.
Do you know if it's what script is it transcribed in? Is it Romanized?
Yes, the writing system for Tamacek I think is Romanized. I couldn't say if there are others, to be honest.
Okay.
But at least I know there is some Romanized transcription of Tamacek. Yes.
Okay, thank you.
Yeah. Yeah. So Thibaut mentioned that there are two writing systems, Romanized and another one.
Okay, thank you.
No further questions. Let's thank Anthony.
Yeah. Thank you.